Hello, this is the luckiest maths teacher in the world, and today we're going to learn in depth a bit more about a certain type of polygon, a triangle. So all I want you to be able to do today is to classify triangles. But before we do that, we need to know what a triangle actually is. So a triangle is any three-sided shape. So remember we said in the last video that something like this, well, that wouldn't be a triangle because it's only got two sides. This curved thing here is not actually a side. You probably know what triangles look like. You would have come across them many times before. But today we're going to look at the different types of triangles. Now, the way we classify them is depending on how many sides or angles in the triangle are equal. So the answer to that varies for different types of triangles. But what I want you to understand is the important point that the number of equal sides equals the number of equal angles. So a triangle can have either no sides equal, two sides equal, or three sides equal. If it has three sides equal, then all three angles are equal. If it has two sides equal, then two angles are equal. If no sides are equal, then none of the angles are equal. And we're going to use this to classify triangles. So let's get started on the definitions. So those three cases that I just stated about whether the triangle has 0, 2, or 3 sides equal, they are how we're going to classify them. So the three types of triangle we're going to look at. First, we look at these types, scalene triangles. So that has three sides of different length. So a triangle, if you were told that this one was 5 centimeters, 6 centimeters, and 4 centimeters, that is a scalene triangle because none of its sides are equal, and that also means that none of its angles are equal. Isosceles triangles, on the other hand, they have two equal sides, which means that they have two equal angles. Now, it's important to note the two equal angles are the base angles, not the apex angles. So in this triangle here, this angle here and this angle here are equal. So where the two equal sides meet the base. Okay, so we can flip an isosceles triangle so it looks like this, and the base is down the bottom. Okay, so those two angles that I marked are equal. Okay, so they're not equal to that one in this case. So the third type is equilateral triangle. So this is a regular triangle. It's a regular polygon, meaning all sides and all angles are equal. Now, as we're going to see in a couple of lessons' time, the angles inside a triangle add to 180 degrees. So in an equilateral triangle, no matter how big or small the triangle is, all angles equal 60 degrees. So all three angles are equal and all three sides are equal. Okay, so you need to know those three definitions. Now, another way we can classify triangles is based on whether it has all of its angles acute, whether it has an obtuse angle, or it has a right angle in it. Okay, so let's just go quickly through what I mean by acute and obtuse angles. So before we go into this, let's actually try and draw a triangle. So let's draw a line down here, and then let's draw another line. So these two lines meet at 90 degrees, okay? So let's say I wanted to join another line and make an obtuse angle. So if I draw one here, this angle here is obtuse. So it's more than 90 degrees, but less than 180 degrees. Now, for a triangle, all three sides have to connect in some way. So if I drew the line here and I wanted to draw a third line to make a triangle, I can see that this angle here is acute. It must be less than 90 degrees. This one here is also less than 90 degrees, okay? If I wanted to draw two obtuse angles, I wouldn't be able to get them to meet. So let's say I drew something like this. So I have normal straight line and I draw an obtuse angle here. If I want from this point here, if I want to draw another obtuse angle, I have to go that way. So you can see the three lines don't meet at all. They don't connect, so I can't make a triangle. So this might be a little hard to understand. You're probably like, well, what is he actually talking about? Well, what I'm actually going on about is that any triangle can have at most one obtuse angle. Similarly, a triangle can have 0 or 1 right angles. So let's draw this case of two right angles. So here I've made one right angle. Now I'm going to put up another right angle. Now, this angle here is a right angle. And I know that you all have amazing memories. You remember when we did angles and parallel lines. Because this angle here is 90 and this is 90, these two are co-interior angles that add up to 180. That means that this line and this line are parallel. What that means is that this line here and this line here, if both of these are right angles, they can never meet. That's why a triangle can only have one right angle or zero right angles. It cannot have two. So because of this, this makes our classification easier. So when we're classifying a triangle based on angles, we're just looking at, does it have a right angle or does it have an obtuse angle? So if it has an obtuse angle, remember it can only have one obtuse angle, like in this case, we call it an obtuse angled triangle or an obtuse triangle. Here, if we have one that has a right angle, remember it can only have one 90-degree angle, the other two angles must be acute, we call that a right angled triangle or a right triangle. So some triangles don't have an obtuse angle, don't have a right angle, and they're the third case. So they are just called acute triangles. So all three of the angles are acute. Remember, in any triangle, it will have at least two acute angles. The third angle may also be acute. It may be a right angle or it may be an obtuse angle. So that's how we classify. So let's look at some examples. So I'm going to go through and classify the three triangles that are now on your screen. So let's start with A. So A is this triangle here. So the lines here mean that all three sides are equal. Now if all three sides are equal, we know all angles are equal. And the name we give to that is an equilateral triangle. Now equilateral triangles, as I said before, they have all of their angles equal to 60 degrees. So they are always acute angled triangles. There's no right angle, no obtuse angle. So it doesn't matter if you put it in or not, but you could write acute angled equilateral triangle. That's A, okay? So let's look at B, okay? So B, we have no sides equal. We could get a ruler out and measure it, but we haven't been told that any of them equal by these lines that we had in the first one, like that one and that one there. So if all sides are different, all angles will be different, and this is a scalene triangle. So we can just look at it and see that all three of these angles are actually less than 90 degrees. They're all sharp angles, they're all acute angles. So again, this is an acute angled scalene triangle because no sides are equal. And similarly, in the last one, there are two sides that are equal. However, all angles here are acute, so it would be an acute angled, and the name we give to triangle with two sides equal is an isosceles triangle. Okay, so I'll just do a couple more examples and then we're done. Alright, so let's have a go at these ones here. So D, we are told that there is a right angle. That's what this symbol means here. It means there's a right angle. We're also told that two of the sides are equal. So this one, its angle type is right angled. So it has two acute angles and one right angle. But because two sides are equal, which also means two angles are equal, it would be a right angled isosceles triangle. Okay, you can never have a right angled equilateral triangle. You can have a right angled scalene triangle, but because two sides are equal, it's a right angled isosceles triangle. So in the last one, let's have a look. So we can see clearly that no sides here are equal. So we know that it's going to be some sort of scalene triangle. So now we just have to decide the angle type. So we can see, well, hopefully you can see the angle here at C. The angle here is acute, as is this angle here. But what about this third angle? So look at it like this. If we were to put our protractor, we have our baseline here. The line that's at 90 degrees would go up like that. So that is 90 degrees, but you can see that this angle is 90 degrees and then we add a little more. This angle's more than 90 degrees. So that angle at B is an obtuse angle. It's more than 90, it's less than 180. So we're going to call it an obtuse angled scalene triangle. Okay, so just as an aside, we normally name triangles and shapes by their vertices. So if you're given a triangle like this with a big A, B, and C for the vertices, we usually call that triangle ABC. So for this last one, E, I could have said triangle ABC is an obtuse angled scalene triangle. Okay, hopefully you found this informative. Please ask if you have any questions. Otherwise, this has been the luckiest maths teacher in the world. Have a great day.